As you know,
This meeting
today
is being recorded.
we'll be moving into a very interesting session, our second and final workshop. Before we dive into today's session, I'd like to briefly introduce our host, the organizers, and the competition itself, as there may be few participants who were unable to join the earlier sessions. So, GenZipher offers a unique experience by blending competitive programming, cybersecurity, and practical system development, designed to challenge undergraduates like you and me to think critically and solve problems creatively. This journey has already begun with an analytical online qualification round and culminates into a 24-hour on-site finale, where participants would focus on building a real-world solution. So now, a brief introduction to our host, the University of Colombo School of Computing. It was established in 2002 under the visionary leadership of the late Professor Emeritus V.K. Samaranayake. UCSC stands as Sri Lanka's leading institution for computing education and research. It is also the nation's first and only higher education center exclusively focused on computing, affiliated with the University of Colombo. UCSC is also dedicated into producing highly skilled ICT professionals who can meet the demands of a rapidly evolving digital world. So now a bit about the organizers. The CSSL Gen Z chapter of UCSC. So GenZipher is brought to you by the CSSL Gen Z chapter, a youth-focused initiative operating as a proud extension of the Computer Society of Sri Lanka. So here our goal is to empower the next generation of leaders by bridging the gap between academia and industry. So through innovation and continuous learning and direct engagement with industry experts, we aim to create a meaningful and a lasting impact within the computing community. So opportunities like this GenZipher provides you with the chances and the opportunity to engage with the industry experts and continue your journey in the computing industry. So now let's move on to our event overview. So about GenZipher, as already mentioned in our previous sessions, GenZipher is built around a unique hybrid concept which blends competitive programming, uh, capture the flag, and real-world engineering. So our objective here is to challenge undergraduates to think critically, solve creatively, and build effectively under pressure. So you might also know that our 24-hour hackathon, on-site hackathon, would be on-site hackathon, and even after that, you will be required to present your solutions. So that is a somewhat pressure. So you guys need to be creative and think effectively and build a complete solution according to those. So one of the unique twists of GenZipher is that the participants must uncover a hidden development theme by resolving the CTF-based hints before building their final solution. So here we don't give you a theme directly that you can directly build upon. Instead, you must uncover the hidden theme using by solving the CTF problems. So this we expect this experience would provide you guys with a valuable exposure to teamwork, modern technologies, and also real-world development frameworks. And now, the most important part of today's session. Moving on to our second workshop today. So it is themed AI Agents, a complete guide, a session that is especially important in today's AI landscape. So we often hear this about powerful AI models, but the real shift is happening in how these models are used as intelligent agents that can reason, plan, and take actions. So this workshop will help you to understand how modern AI agents work and explore practical workflows used in real systems and discover emerging patterns shaping the future of AI development. So, and most importantly, this also bridges the theory with hands-on practice giving you skills that are not just relevant today, but also, hopefully, future ready. So, whether you are new to AI agents, I'm pretty sure that none of us are new to AI agents, but even if you are and all and already exploring them, this session will give you a strong foundation to build on. Right. So, before I invite our speaker for today's session, I'd like to take a moment to acknowledge one of our most important sponsors of GenZipher. So let's now turn our attention to their video. Thank you. Thank you. So now, to guide us through this wonderful and exciting workshop on AI agents, a practical guide, we have with us Mr. Pasan Jayawardena, a software engineer specializing in AI and research and development at Insecure. He works closely with real-world AI systems, focusing on building practical, production-ready solutions, making this session especially valuable in understanding how AI agents are applied beyond just theory. So we are excited to learn from his industry experience. So without any further delay, let's warmly welcome Mr. Pasan Jayawardena. Over to you, sir.
Thank you, Sadhavina, for the wonderful welcome. I hope you guys can see me, hear me, and I'll just share the screen. Another thing, my screen is already shared. I don't know. I don't have a presentation. I have a repository that I have created to like conduct the session. In there, we have a readme. I'll send you guys the link. In the readme, you will see the like theoretical part of the session. So how can I access the chat? Great. So if you go to this GitHub repository, you guys can see the README as well as the code. I'm not going to code right now in the session. It will be like waste of time, but I'll explain what I have written and like how to run it and all. First, you guys can see me, hear me, and all things are right. Okay, just because I'm just asking because no one is responding on the.
Yes, so we can hear you and see you very clearly.
All right. Yeah. How many of you have, let's say, implemented a React agent from scratch or just used a framework to implement a React agent? So React, I choose React because it's the most fundamental uh, AI agent out there. If you understand React, you can understand any other agent. Maybe it may be a deep research agent, it may be a deep agent, any other kind of thing, because React has this fundamental loop of tool calling, observation, and that fundamental loop. If you understand React, you can like understand the frameworks and understand how other kind of agents are implemented as well. So just want to ask how many of you have uh, maybe interacted with a React agent, or have uh, implemented a React agent from scratch, or maybe a framework. Can you guys just, if you guys have done it, just can you guys raise your hands? Uh, can't s- uh, Nobody has done it, or just mm, yeah, these modern agents that we interact are uh, more complicated. I'm just asking about the most basic kind of agent, React agent. Yeah, then it's good. I can teach you guys. So, like I said, I don't have a presentation or anything. Uh, I'll shared you guys the repository. That's where my new materials are. I'll just This is the repository. I'll just go through the README when I explain you guys the things. So React is the most fundamental kind of agent that you can implement or interact. Uh, so so if you understand React, like I said, you can understand any other agent. And uh, even in deep agents and deep research agents, this loop is there, but in a more complicated manner. Uh, and React agent is the first kind of like most like first kind of agent that we saw in the industry. Like after the Gen A things, this is the most first Gen A agent. There have been agents even before that. So I'm just saying this is the most like after the Gen A. This was the basics for the modern agents. So I'll just explain you the architecture of the React agent to you guys, and then show you the implementation and run it by myself. You guys can just go to the repository and try to run it yourself as well. So this is the like kind of the workflow of a React agent. I hope you guys can see this GitHub README I'm sharing. If not, just let me know. So in React agent, there's a loop, right? So you guys can clearly see there's a loop, right? So, and uh, I'll go through the loop. So let's say the user asks a question, and this agent is can be customized for anything. So there's a after we ask the question, according to the prompt we provide to the LLM, it can either decide to take an action or answer the question directly, right? So take an action in the sense you guys might have heard we can do tool calls with agents, right? Agents. So even in the LLMs, we can just give the spec, like spec in the sense what are the arguments that we kind of need to invoke a function. When you do that, LLM will generate the uh, kind of the example argument for uh, the function, and we can just go ahead and call the function with that arguments. So that's the action. So action in the sense that it will select the with the prompt LLM will select the tool that it's going to call and the arguments for it. And then if it uh, chooses to do a function, like do a tool call, then what it does is it waits for the tool output, and uh, tool output in the sense the function output, and it observes it from that result, and then again go to the this thought section. Thought means the reason section. According to the observation, it again decides whether to sorry whether to do a tool call, or with the observation go for the final answer. So this loop is uh, uh, continued until it gets to a final answer, and until it doesn't have a tool call, and LLM decides, so this is the final answer that I want to share to the user. Until then, this loop continues. So there was a time uh, that we defined AI agents as L- LLM agents as LLM calls in a loop, but now it's much more complicated than that. There's memory and context engineering, that kind of things. But this was the fundamental thing. Also, you guys can see this is a loop, and the loop is controlled by the LLM. This thought, observation, uh, things are just decided by LLM. So like I said, when I'll go through it again. When user ask a question, uh, LLM decides to whether to take an action or give the final answer. If it is an action, uh, it gives the tool output, like sorry, tool, what tool to call and the arguments for the tool, and we go ahead and invoke the tool. Uh, then LLM wait for the tool output and do get the observation of the tool output and think for itself again whether to call another action or give the final answer. This loop is continued until it decides these are the all information I need, and then I can give a final answer, right? Yeah, this is the theory part actually. This won't make much sense, but I'll show you guys this the implementation I have done. Uh, Wait, I had it. Mhm. Hope you guys can see my terminal as well. If not, let me know, because I just wanted to like do these things up front. Uh, I have the repository cloned here. I just open cursor. Um, yeah, right. If you guys go to this React uh, notebook, this first notebook, I'll just clear all out for now and then show you guys what's happening. I'll have to uh, define my .tnv file here. So the OpenAI key I'm getting from a .tnv file. I can't show you guys that obviously. I'll just stop my share for a moment and then get it done. Uh, let's see. Uh, okay, it's done. I'll share the screen again. Right. So I'll go back to the cursor. I have uh, copied my .tnv file here. So I'll just go through the code, then you guys can understand better what I was talking about from about this loop and all. I'll just first import. Uh, so this is a UA project that I have created. I will just initiate it, and So you guys can see my terminal and all right. I have at the full screen.
Yes, I. It.
If you guys can't see your anything, just let me know. Right. This is a UV project. UV is the package manager for Python that I am using. It's very fast written in Rust, much like Node.js for JavaScript or Maven for Java. I just initialize this project. It's a UV project. I'll just sync it. And now the dependencies are installed. The command was UV sync. This of the command. And then let's select a Python environment for this one. Yeah, I need to install some other things. Until then, I'll just explain you the code as well. And this is just importing the necessary stuff. And then I initiate the OpenAI client. That's because that's where we interact with the LLM. And then this block is for just testing whether the key works and all. So it's just a call to the chat completions API of OpenAI. Also, guys, there are easier ways to implement this even in with OpenAI, but I'm just doing the most basic implementation, so it is easier to understand and all. Uh, let's see whether this code runs. Uh, since it's not working, uh, it's not working. I might have other thing set up. Uh, it's downloading some packages. Give me a little time. Yeah, I have a backup ready, and I'll just have this there. Right. This is the same code. Uh, so here just I'm just importing whatever required, and then like I said here, I have I'm just checking whether this is working. Just I'm just saying to the LLM, this is a pretty standard LLM call to the OpenAI API, just the chat completion one. I have selected GPT-5 mini as my model, and I'm just giving user message as hi. It gives me the chat completion object, and we can see, yeah, yeah. It says hi. How can I help you today? So it's the LLM message. So that's not our goal here actually. So I'm here like I'll just tell you guys about the agent code. Uh, yeah, right. So this agent class is just for like the standard stuff. So this init is the constructor of the class. So it just takes a system prompt and append it to the messages block. System prompt is the main prompt that we are giving to the LLM, and this is what we call a dunder method in Python. So it's nothing but just a way to interact with the agent object without a creating object. I'll show you guys that. So what this method does is it gets a user message and calls the chat completion API. Chat completion in the sense it sends a question to the LLM and get the answer. So get the answer and append that answer to the messages object, and then just research, uh, send the user the result of response from the LLM, right? Uh, I'll just run it as well. And this is the important part. So this prompt, this is the master prompt of the agent. Uh, I'll just run you through the main things of this. Like we tell it you run in a loop, and the loop is thought, action, pause, and observation. So at the end of give an answer, and uh, use thought to describe your thoughts, action to take actions, and then return takes action, and then return pause, uh, and observation uh, will give when you give an action for us to do, we'll give the observation to you with this observation block, right? And then we give some actions that it can perform. So because it needs to know the actions that it can perform, right? uh, so also this example is like a flight booking system. I didn't have like uh, proper example in my mind. I just thought this would be good. So these are the three actions it can take: calculate, get flight status, get weather. Also, these are just placeholder functions. I'll show you the functions uh, in a later block. So calculate does is we just give it a some context about how it does, how it can perform this section. Example, calculate, runs the calculations and return the number. Uh, and we give the get flight status action as well. So when we give a when we give a like this value, get flight status and some value for a plane, it will give the flight description and get weather. We it need when it needs to get the weather, it needs to like uh, specify the tool I want to call is get weather and the name of the city. It returns the current weather of the city. So also we give it an example. It's a good prompt engineering practice to give an example for an agent. So this is I'll go through the example session as well. So user asks a question, what's the status of flight JL001 or something like that. So then the LLM should think I should look up on the flight status using the get flight status, and then it should give us the answer get flight status and the plane number, and then pause. And then in our end what we do is we actually call that function and get the answer. And so we tell the LLM that you will be again called with this observation. So this is the tool output. And then it should think like it should go to the thought status again. So it should think like I have a flight status, now I should check the weather in Tokyo. Like, so this should, so that's one mistake in here. The question should be like, what is the status of the flight, uh, and the weather in the destination. Like, like this is like some kind of a complex enough question. So it gives the Tokyo as the destination. Then it should think like I have the flight status, now I should check the weather in Tokyo. And it should call then the get weather function with value as a Tokyo, then pause, and then we call that tool again and get the weather. And this is the function or tool output. We say tool in LLM world. And then it then the LLM should output like the flight in whatever the uh, whatever the information it gets from the tool output, it can just paraphrase it. So that's the main prompt of the agent. And here I have just defined those function as well. It's just some placeholder functions. So here you can see I'll just from the calculator I'll just run the eval function and get the calculation result. And I have just two flight IDs and some random flight information returned with the flight ID. And get I have just London, New York, and Tokyo. And just these are just placeholder functions. You can just plug in your own functions to this as a, so you can just customize this to your own use case. And I have just uh, defined the dictionary with the function and the function just key and the function itself. Run this as well. Right. Then I'll just initiate the agent with the system prompt that I have created. This is the system prompt. I'm just initiating the agent class. Agent is nothing but the class that I have shown you earlier. And then I ask it like, it should be changed. Something like, what is the status of flight? SAS. Is the status flight? And without the destination of the flight. We ask that we'll should get the result. Yeah. So like we said, it just thinks I should look up the flight status using the get flight status, and then it gives us the get flight status. And this like this uh, argument for the function as a, so we just have to like we can automate this. I'm just showing you the bare bones of the agent. So I'm just manually calling get flight status with this uh, one and that the agent have provided us. So it gets a observation, and for the observation, and then we give the LLM the next prompt like observation. We format this result with this observation block, and then we see the next prompt. We can see the next prompt for the agent. So this is the next prompt. It's a delayed flight and destination is nowhere. And then we again call the agent with that next prompt. So this is just calling that random method that we have defined. It just append the message and call the LLM completion API. So this is the output. I have the flight status of the destination of New York. I should check the current weather in New York, and then it gives us an action as well. Get to the New York. So what we have to do is uh, we can just call get weather, and this is the argument it gave us, and we can just uh, format it with the next prompt observation, and we can see the next prompt as well. So next prompt the weather uh, observation, the weather in New York is cloudy and 10 Celsius. It's just the return from the tool. Then we can call the uh, agent again, right? I'll just call the agent with the prompt, and yeah, let's see the output of that. Yeah, the flight is delayed and the destination is New York and where is currently cloudy and 10 Celsius. So this is what happens in an agent. So next step, I want to like automate this and create do in a loop. So I'll show you guys that as well. I had it somewhere with yeah. Then this is the uh, loop that I was talking about. So this is the like most basic uh, agent you can create. Before that, we just get a regex defined, so we can just extract that tool call from the LLM output and call that uh, tool by ourselves. So I'll just explain this to you as well. So what happens? It gets a question, and also it initiate the agent with the agent class that we had, and the next prompt we get the question, and the next prompt is equal to next question, and we define the max iteration. This is for we can like go in the loop forever, so we have to stop it. So we give a max iteration as well until uh, it's below the max iterations. We loop until that, and what happens is we give the next prompt to the bot and then get the results, and then we check whether there are actions that we can take from that result, like whether the LLM output has actions. If so, we can, if there are actions, uh, so this code block what it does is just calls that action from the known action dictionary that we had created, and if we get the observation as well, and we get the next prompt as well, and then we go in this loop, right? And else if like uh, uh, so this happens if there are actions, right? If there's not any action, it just uh, return to the user, Right. This is the same loop that I was mentioning in that report. Uh, so this is the one. So if there an action, we go ahead and go through this loop. If there's no action, we get to the final answer. Uh, right. So this is that condition over there. If there is action, goes ahead and get to the action. If else, it returns. Right. See how this works. I'll just get the same question that I had asked earlier. Yeah, this is the one. Intermediate distance line. Oh, yeah. So this should call the get flight, like just like the last time. It should call the get flight information tool, and then according to that tool output, we should call the like getting the weather of that destination city as well. So we can see the whole output here as well. First, it things we should look up the flight status using get flight status. It gives a get flight status and pause. Then we get the tool out. We call the tool and get the tool output. So we in this loop we recognize there's a uh, action block, and then we call that action, and we give the result to the LLM, and then it again thinks like I have the flight status for this flight number, and now I should check the current weather in New York, and so because the New York is the destination, and it asks to get take the action of get weather with the argument New York, and so then we again go ahead and run it programmatically, and gives a observation call. The weather in New York is cloudy, um, and all of that, and then LLM decides in the next iteration it doesn't need to call any tool. It just can get to the answers, get to the answer with this information that is available, and it gives the uh, final answer to the user. Flight is delayed and the destination is New York, uh, and it gives the uh, weather of that city. So this is the like most basic form of agent that we can use. This is the React agent, but uh, we almost never use this kind of bare bones structure in the industry. We use some kind of framework, but knowing this fundamental thing is very useful for you guys. Uh, yeah, if you guys have questions, just let me know. You know, it might be a lot to take because some of you might not know what a tool call is. I just had to you because without tool calls, you guys can't code agents. It will take a little time, but I have just listed these things in the repository. You guys can literally go through. There are like some mistakes, seem to be some mistakes in the repository as well. I'll just correct them as soon as possible. And that was the most basic form of agent. And this is just the second code is just putting it in a .py file. You guys can just run it by yourself. And yeah, if you guys have a question, just ask me directly. It's fine. Just unmute yourself and ask. And then I want to just uh, show you guys how to do the same thing with the framework. It is quite easy. You don't have to like write very long code. Just frameworks makes it easy. There are a lot of frameworks. The most popular one is these days LangGraph, but I thought of going with some other framework because this is also a real good framework, but people don't use it very much. People don't use it as much as LangGraph. So, but I want to introduce you guys to it. Anyways, just choosing a like frameworks doesn't matter if you guys know the basics properly. So just try to understand the basics really well. But for the like sake of completion, I have included this way to uh, like do this with the frameworks as well. Same example I just explained to you guys. So what it does is like we uh, just import the DSPy framework and then just initiate the LLM and with the OpenAI key, and we uh, define the uh, tools. So in the tools, we give this like nice little uh, expressions on what is the tool, when to use it, and what are the arguments should be, because this is what the framework will be using for uh, deciding when to use the tool and what will be the argument. So for example, for this calculation, look, sorry, I'll explain you guys the get flight status one, so it will be easy with the current context. So it just says this function, this tool returns the current status of a flight, including gate and destination and those kind of things. And it says the argument should be the flight ID should be the flight identifier, and it has given an example as well. And this string will be given to the LLM as information on how to when to call this tool and how to call this tool. And these three, so this is like same thing in all three tools here. And then in DSPy world, there's a thing called uh, signatures and modules. Modules are the like show you guys the React thing, right? So modules are the abstraction of that kind of workflow. Signatures are like what should be the input to this workflow should be, and what should be the output. Like uh, this is a signature that I'm creating. So in that I'm saying you are a helpful assistant that can check priority status, whether and perform calculation and that kind of things. And I give it the input and output as well. And I can give a little description is if I want to, like so for the output will I say a detailed answer to the user's question on based on the tool outputs. And I can give a description in here as well, but I haven't given it. Let's give it the user's question, right? And what you can do is you can just uh, initialize a React agent using the React module in DSPy. So the uh, uh, syntax for this is just dspy.react. It's already like abstracted away the details and all of it. How to do this thought observation loops and all, it's in this React uh, module. And we give the available tools to it, and the signature we created. So signature tells what are the inputs, what are the outputs, and a brief introduction of what is what kind of agent you are, right? Um, and then what we do is just we just uh, run that React agent with the question we have. Uh, let's try it, shall we? Uh, so, so this is a UV project. I'll say UV run DSPy React file, and I'll get this question. be working. Let's see. So this is with the framework, right? Let's see whether this works. Oh, yeah. It gives the final answer because I haven't had like print statement or logging or anything. It just runs it inside the module and gives the status of the flight and it is currently grade 5 and that kind of things. And destination is London and London is sunny with the temperature of 15 Celsius, so that kind of things. Let's see if it's right. BA123, right? Yeah, BA123 is London, and London I have cities as sunny and 15 Celsius. Yeah, works. So this is how we do it with the kind of a framework. And yeah, so I think these are the things that I want to teach you guys. Going forward, just I know it might be a lot to take in just one session. Just I'll just upload this repository to uh, GitHub, and then you guys can take a look. I'll just push it, and there are, I think, some mistakes I have made. I'll just correct it and do another push as well. Uh, and going forward, just uh, try to understand this basic pattern, and after you do that, like get to a framework. Frameworks are fun as well, but you need to understand the basics really well, and then go to framework. And if you guys like DSPy, there are inbuilt ways to do observability for LLM apps as well. So that's fun as well. Observability with ML flow is built into DSPy. You guys can explore that as well. I don't think we have time for that. Uh, yeah, those are the kind of things. If you guys have question, you guys can ask me. Uh, yeah, let's see if there are. Yeah, yeah, that's kind of it. Just try to understand the basics, try to understand the, then go to framework and build something. And also, if you are going in DSPy, ML flow observability is built in. If you are going with LangGraph or anything, they have a observability platform as well, called Langsmith. I'm talking about these observability platforms because that is also a fundamental part that you guys need to understand when it comes to productionizing these things, because these are unpredictable workflows, and even agents are very unpredictable. You guys uh, need proper observability configured when you run in any kind of applications that the users use day to day for day to day activities. Yeah, that's kind of the things that I want to share. Hope you guys learned something. Yep. I'll just stop the sharing. And if you guys have questions, just ask right now. I'll just put my LinkedIn and email here so you guys can reach out to me. The LinkedIn, and this is the email. Yeah, thank you guys. Seems, is there any questions?
Thank you, sir. And before we move on, I would also remind you again, if you have any questions, you can ask and even contact Mr. Pasan using his LinkedIn for his email. And yeah, so thank you again, Mr. Pasan Jayawardena, for an insightful and a very practical session on AI agents. So your guidance today will help us to bridge theory with real world applications and give us a valuable insight into a future-proof AI systems. So we truly appreciate your time, effort, and willingness to share your expertise with the GenZipher community, even with your busy schedule. And sir, and to everyone as well, before we conclude today's session, I would invite everyone to switch on their cameras and to take a small screenshot of today's session to capture the moment. So your background images has been background image has been uploaded, and if you guys can, please switch your background image to that. And even if not, it's okay. Just switch on your cameras. I would like give 30 seconds or so. And after that, I would give a countdown and then we'll take the screenshot, right?
Yeah, just a moment. Thank you guys for inviting all the for all the organizing community, and thank you for the wonderful work that you do. And thank you for all the participants for listening here today. Yeah, thanks, guys.
Uh, and guys, please switch on your cameras. All right. I think that would be enough time to change the background, and I would give a small countdown. After that, I would take the screenshot. Right. So, three, two, one. All right. Okay. Thank you very much. And so hopeful, I hope that all of you got a very good understanding about AI agents and how their workflow works. And so what's up next? And what's up next? So next is our on-site grand finale of GenZipher. So more details will be revealed very soon. So stay tuned with us. And thank you everyone, especially Mr. Pasan and all of you as well for coming today and joining today's workshop. So thank you and have a great evening. Good night.